All right. So what we're going to start out with ones that are more or less like this. We have to be able to determine the least common denominator in order to do this. All right. If you want to try to solve this equation by adding and subtracting all that, you can go ahead and do that and try it. I'm not even sure I would want to mess with it. So the best way to deal with fractional equations that have fractions in them, is to find the LCD. And you're looking at these three numbers, the three, the six, and the three. Well, there's only a three and a six there that's unique. And least common denominator means the smallest number that all three of those will divide into, which is six. All right. Can't just use three because six can't divide into three evenly. So now, once we do that, we divide everything, multiply everything by 6. Remember, it's 6 over 1. So when you multiply this first one by 6, the x minus 2 over 3, the 3 goes into the 6 twice. And so you're multiplying 2 times what's left, which is the x minus 2. On this one, the middle term is just x over 6. The 6's take each other out. Remember, that's 6 over 1. All we're left with is just the x. And then here again, 6 times 4/3. 3 goes into 6 twice. 2 times 4 is 8. Well, and so, or it's going to be 8 down here the next step. And you got to remember, when you multiply something in parentheses like that, you got to multiply both the terms. 2 times x, 2 times -2, 2x minus 4. The x just comes down, and then that's simple. 2 times 4 is 8. And then after that, it's just a normal equation. Now, there's no way to really go through the whole check during a lesson, but I want to select certain ones to check. All right. This is going to be important, especially in the second example. All right. But you can see we've come up here with x is equal to 12. So if you put 12 in here, 12 minus 2 is 10 over 3. And then this is 12 over 6, which is 12 over 6. And then this one is just 4/3. Well, what you're going to have to do to check them is almost harder than solving the thing. Is you got to find a common denominator for these two to add them together. Or what you could do is just put this one over here, and it becomes negative 4/3. So 10 minus 4 is 6/3. And so what you got left then would be the 12/6. And both of those happen to 2. So it would check out. All right. In this section, like I said, it's important to check the answers, but there's no way I'm going to be able to show you the check on all of them just because of time constraint. I was doing that this morning and I ran into trouble. I was trying to do all of them. But my first question for you today is, for this first problem, what is the LCD?
It's
One's
10.
repeated, so we only have to look at these two. It's 10, right?
Yeah.
All right, so multiplying everything by 10. And remember, it's 10 over 1. And if that LCD is picked correctly, and if we do the multiplication correctly, then we will have no more fractions. That's the whole point of doing this. The twin over 1 is kind of more just a formality, just to make sure that we line up the numerator with the numerator. Okay, here, see 5 goes into 10 twice and into itself once. So we're left with 2 times 2x Here, the 10s go away completely. Those are just 1 there and 1 there. So it's just plus 7x. And then here, again, 5 goes into 10 twice. And 2 times negative 11 is negative 22. So 4x plus 7x is equal to negative 22. So what do we get for an answer? We get 11x is equal to negative 22. Dividing both sides by 11. We're still using the same old rules with that. All right, and so I'm just going to kind of spot check this one. Negative 2 substituted for x gives us negative 4 fifths, because 2 times negative 2 is negative 4 over 5. All right, negative 2 times 7 is negative 14, and it's over 10. And then this one doesn't have a variable. It's just negative 11 over 5. All right, if you put these two together, this one is going to be, to get the LCD, you got 8 fifths negative. Minus 14 tenths. Oops, this should be tenths, I'm sorry. Because we're doubling it in order to get to thing. So 8. Hold on a second. What did I do? Oh, I'm sorry. See, it's negative, negative, so this is positive. So negative 8 and 14. Hold on a second. What did I do? Negative 8 over 10. I should have left my the ones up there. They just did this morning class. All right, let's see. What did I do? 4 fifths. So we got to double this to give it a 10 denominator. And this ends up being plus, because it's negative times a positive gives us negative 14 tenths. And then this is oh, okay, I'm sorry, I'm just crazy. So this comes out to be so 8 from 14 is 6 tenths. All right, I'm going to come back to that. All right, I'll probably look at my video from this morning and see what I did, but like I said, I'm trying to check certain ones just because of the time factor. But that's right, because I remember that. I just don't know why I'm getting negative 14 over 10. Which ends up being positive. All right, we'll come back to it. All right, so just answer me the question here. What's the LCD? If you got more than one, it's going to be the larger one. I know that's kind of counterintuitive from the word greatest common factor. I mean, sorry, least common denominator, but that's the way the least common denominator works. It's the smallest one that all three of them will fit into.
24.
Yeah, so we got to multiply everything by 24. And remember, that's over 1. I'm just not going to put it there. This thing, too, if you try to write too fast with it, it doesn't register. Oops, what am I doing? It's just 24. And it's times 5x over 8 is equal to 24. So that's x over 24. Now, hopefully, like I said, since this is over 1, you can see that that's gone, and all you have left is just the x. Here, 8 goes into 24 3 times, and so 3 times 5x is 15x. 4 into 24 goes 6 times. 6 times x. All right, now this is a crazy one. I don't know why in the world they put this one in here, but what's the solution that's going to be? If you've got all x's in every one of the terms, it's going to be x is equal to 0. So 21x is equal to x. So when we subtract x, 20x is equal to 0. And so now this one is easy to check, because if x is equal to 0, 0 over 4, and 5 times 0 is just 0. So that's just basically 0 is equal to 0. So that's right. All right, see if you can do number 3. Identify the LCD, then multiply everything by the LCD. See, these are over 1. So there's really only one thing down there. It's not 1, and it's x. So the LCD is x. Multiply everything by x. And when we do that, see, those x's are gone, and you're left with just a 7 negative. You can write it like this if you want. I like to see it like that if I can possibly help it. So x is equal to -1. All right, so this is one that I want to check, because this is fairly easy to check. If you're like in a rush situation, like with a quiz or test, there's nothing wrong with skipping, but you need to spot check things, and we'll see why on number 4. But this one is really easy to check. The best place to check is when you're doing your homework, because it'll build up confidence. Because if you check and it comes out right, then that's going to build up your confidence. So if you have to rush in a situation like a test, you might be able to forego testing, but you got a couple of other things you need to deal with, like in number 4. All right, so this one's only got one place to put an x. So this is 2, and this is -7 divided by -1, which is plus 7. And you know what? 9 is still equal to 9. So see, we've got the added assurance that we've done everything correctly on that. Now, look at number 4, and what is the LCD there? This is the first one we've seen that's got a
It's going to be x minus 2.
exactly, it's x minus 2. All right, but both of them are the same there, and then this is over 1. So when we multiply everything by x minus 2. So these are going to be gone because that's x minus 2 over 1. These are going to be gone. Same thing. So this is just going to be 3x minus 6 is equal to 6x minus 12. All right. It's minus 6x minus 6x. There's nothing to combine. And then we're going to plus 6 on both sides. These are going to go away. These are going to go away. And what are we left with? We're left with negative 3x is equal to negative 6. And so when we divide by that negative 3, we've got x is equal to 2. Now, does that check out as a solution? I want you all to look at that in a minute. We need to be very, very careful about this because that's going to teach us a very important lesson. Because this goes back to section 6.1. Remember over there where you had to check for values that make the denominator undefined? So
at 0 equals 6.
Well, you shouldn't even get that because watch. The important thing is what happens in that denominator. What is that equal to for that first term? That's 6 over 0. What's wrong with that? The same thing's going to happen with this one. It's 6 over 2 minus 2. So what that does is it makes that original equation or both of these expressions here undefined. So let me write that down. So this is why it's important to at least spot check, because of the fact that if we end up with an expression that's undefined, given that solution, then we have to throw it out. Because that's not 0. 6 over 0 is not 0. It's undefined. All right, so last two here. What's the LCD on this first one?
6.
Yeah, so multiply everything by 6. What happens when we multiply everything by 6? Remember, that's 6 over 1 if you need it. So these are all on, that's just 3. 3 goes into there twice. So it's 2 times x minus 2. And then this is going to take that out, and that's just 1. So it's minus x plus 1. So 2x minus x is just x. Negative 4, negative 1 is negative 5. So plus 5. So x is equal to 8. Now, we don't have to worry about that making this undefined. So we're not going to throw any solutions out, but it would be helpful to know if it works. And this is the procedure. You just put it back in there. All right, so 8 minus 2, 8 plus 1 over 6. That's a 1. And it's a 6. Is equal to 3, 6. All right, so 8 minus 2 is 6 over 3. And then this is 8 plus 1, so that's 9 sixths. All right, let's see. What's the easiest way to do this? I said is with the fractions, sometimes the checking is harder than anything else. So let's see. I tell you what, I want to add 9 sixths to both sides. So if I take that and add it to get rid of it over there, it's going to be plus, so it ends up being 12 sixths. And you know what that simplifies down to? Well, both of these are 2, right? So I just wanted to show you about the checking. It's important, and if you don't make any mistakes, then something like this is not a priority to check. But something like 4 is, so you have to at least look and see whether it makes that undefined or not. If I were you, what I would do, I would try to check as many as I can in the homework to build up the confidence to make sure, so you know you're doing it right. And then if you're in a pressure situation, you can go ahead and just look and see what the values are that make it undefined, and you'll know immediately if there's no solution. All right, I'm going to rewrite this one to make it a little bit easier to find the LCD. All right, that one right there factors, and I'm hoping that it's going to factor into these two. And I know that I'm right because there's only 2 factors of 3, 3 and 1, and they have to be opposite signs because that's negative. The difference between 3 and 1 is 2. So this is just x plus 3, x minus 1. All right, so the LCD for that is x plus 3, x minus 1. So that's the LCD. So I'm going to try to squeeze all this in there. It's real hard to get it in there, but we're going to do it just so I can show you what happens.
Professor Cruz?
Mm-hmm.
I'm sorry, I'm just moving a little bit slower today, but can we go back to problem number 5 just for a minute?
Mm-hmm.
I just wanted to see where I went wrong at.
Did you get the solution?
Yeah.
Or are you talking about it on the check?
On the solution, I think
Yeah, 8
I
minus 2
did.
is 6 over
It-
3.
I messed up because of the minus.
Yeah,
The
this ends up being minus, but like I said, is if you add 9 to get rid of it over here, you can put it on this side, and they're both positive, and then it ends up being 9 plus 3 is 12 over 6, and both of those are equal to 2.
Okay.
Does somebody else have a question? I thought I heard. All right, so on this one, we got to multiply everything by these two terms, and I'm going to see if I can squeeze them in here. I found a neat little tool that'll write out the steps for me, but it'd probably take me longer to type it all in. The benefit is that they can make it look nice and pretty when it comes out, the solution, but okay, so this is times 2 times x plus 3. So every one of the terms is getting buzzed by this x plus 3, x minus 1. And if we've done it correctly, then there will be no more fractions, no more rational expression. Wait a second. Okay, that's right. And then x plus 3 and then this is negative 13 over x plus 3, x minus 1. All right, so on this side, hopefully it's obvious. Those whole things go away, and all you got left is the negative 13. Here, it's just the x minus 1 that's gone. And so you've got 3 times x plus 3. Here, the x plus 3's goes away, and you got 2 times, so this is positive right there. And then this is 2 times x minus 1. So then multiply all the way across. On that, both of them. Multiply across there. 3 times x is 3x. 3 times 3 is plus 9 is equal to 13. These go together, these go together, so that's 5x plus 7. Get rid of that one. Get rid of that one. So that's 5x is equal to negative 20 x is equal to negative 4. All right, so that one's going to be a bunch of spaghetti to check it, so we might leave that one. If you want to see it later and we got time, I'll come back, or when we review on Wednesday. But like I said, I had to even skip a few problems this morning because of time factor. I don't know why I thought I could get all this in, but I just misjudged the time. All right, now these, and look how, and again, you don't have to put in all these steps, but what's going to be different about these is you're going to end up with those quadratics. See how we got that there? And those are going to factor with two solutions that you have to check. But anyway, the procedure is pretty much the same as this last one in 6. All right, because this one right here factors as x plus 5, x minus 5. And so you can see that the LCD is just those two things, x plus 5 times x minus 5. Multiply all three terms. See, the x plus 5s go away, and you're left with x minus 5 times 1 on this one. The x minus 5s are gone, and you're left with x plus 5 times x. And on the extreme right-hand side, everything goes away but the negative 10. So 1 times that is just x minus 5. This is times x, so that's x times x is x squared. X times 5 is 5x, bringing down the negative 10. Combine the like terms, so that's x, and 5x is 6x, and then bring the negative 5 up front. Then add 10, and you got plus 5. So x squared plus 6x plus 5 equal to 0. Now we gotta just factor this. It's the only way to solve it, because this is a quadratic. All right, so it factors as x plus 5 and x plus 1 because everything's positive. Now, you got a solution here of x is equal to negative 5 and x is equal to negative 1. Why do they
The sound just went out.
solution is not viable, as they say? But if you put in negative 1, well, you got 1/4, you got 1/6, and then 1/4, and you got to get your LCD, but it comes out right to 10/24 or 10/24. So let's see if we can finish these. The only thing that's different is you're going to end up with a squared term in there for your x, so it's going to have you're going to have to solve by factoring. What's the LCD on this one?
X.
Yeah, it's just x. So then multiply everything times x. X gets multiplied by x. This is the only one that's really affected. All right. And then this is negative 5 times x. See, these x's come out, and that's just 1. So x squared minus 24 is equal to, wait a second. Oh, and then this is multiplied by x also. It's just, I forgot it. That's what that is. It's x. Went back and it looked like a 1. So that's negative 5x. So that's going to come over here and be in the middle. It's going to be positive. So then you can factor that. Isn't that 5 and 3? I'm sorry,
Is that
8 and 3.
Yeah, 8 and -3.
Yeah, positive 8 and -3. And just you can kind of extrapolate here. We are actually looking for zeros here. That's what we call the zeros. Another word for the solutions is called the zeros, because um, when we solve that equation, both of these terms are going to make it 0. That's why in 6.1 you solve, the denominators for 0, so you can find out what's going to make it undefined down there. And x is equal to -8. Oh, well, there's another 2 down there, right there. That's the one that's kind of mean right there. It just takes a long time. This one's actually pretty easy. And this one is pretty much just like what we looked at over here, except it's got 2. It's pretty much just like, well, it's sort of like that one. All right, so let's just kind of spot check. Let's say if we got -8 minus 24 over -8, and that's going to be positive. So this is -8, and that's negative by negative, so that's +3. So that one's good. Does the other one look good? 3, and then that's 24 divided by 3 is a -8. So 3 take away 8 is -5. So they both check. So what's the LCD here? You got a choice between x and x squared. And it's got to be the x squared, because both of the terms have to fit in there. So this is going to be x times 1 this is x times 4 over x, and this is x times, I'm sorry, this is x squared. I said it and I didn't write it. And that's why it can't be x, because if you don't use x squared and you use x, then then you'll still have an x down there. See here, the x goes into x squared one time, so there's just one x left. But here you get rid of both of them, and that's what you need to do. So x squared minus 4x, because that's x times 4 with a negative sign in front of it. And that's equal to 2. I'm sorry, 21. So when I subtract 21, I get x squared minus 4x minus 21. And then this one gets factored. All right, this is negative, so it's x plus x minus. I said it and I wrote it wrong. They need to be get rid of anyway. That'll be terrible. X plus and x minus. So there's only a couple of there's only 2 factors of 21. There's 3 and 7, which has a difference of 4, which is what we want. And since that's negative, then your largest one has to be that one. So that when you add up 3, positive 3 and negative 7, you get 20. You get negative 4. Or I can't make a negative 3 for nothing. And then this is x is equal to 7. All right. So again, you can put them in here to check. If you, I'll just do spot checking. Well, 1 is just going to be 1. If you put negative 3 in there with its negative, so that's plus 4/3. Plus 4/3. And then this is 21 over 9. Well, those look nothing alike. Well, let's take an easy way around. All right. So 3 goes in 4, so that's 3/3. So that's 7/3. And if you divide both of these by 3, you also get 7/3. So that one's good, and we'll just kind of go through this other one quick. Okay, 1 minus 4/7. That one stays negative because the 7's positive. And then this is 21 over 49. All right. What in the world do I do? Okay, that's probably right. So then this is going to be 1 is 7/7, so this would be 3/7. And you know what? If we multiply this by 7, we get 21, and we multiply this times 7, we get 49. So this is right. Like I said, and that's a 21. I'm sorry, that's a 3. Because if you divide this by 7 into this, you get 3. I'm going to have to take that off. There we go. So that one's right too. All right, the last one we're going to try to work on here is that one. I've got it over here. This one worked out for the most part. So see if you can do 9. I'll give you a couple of minutes. And this one right here is just x minus 9, x plus 9. All right, well, I'm going to do this one pretty quick. If you got questions about it, you can ask. But when I multiply that first term by these two, I've just got x times the missing one, which is x minus 9. On this one, when I multiply this by those two terms, the x minus 9 is gone, and I just get x plus 9. And the good news is on the other side, this is just x plus 9, x minus 9. So when I multiply, all I got is negative 25. So that's x squared minus x minus 9. So that's x squared minus 9. And then we're going to plus 25. Plus 25. Because we got to make this a quadratic. So this is x squared minus 10x plus 16. Oh, it's just all of a sudden, is it me, or I'm just getting tired, or is this thing not working? All right. So this just ends up factoring as x minus 8. X minus 2. Because 8 times 2 is 16. 8 and 2 negative is negative 10. All right, so you can see up here, the only things that are going to make this undefined are 9 or -9. Because if you got a +9, it's going to make this one collapse, and it'll make this one collapse because 9 minus 9 is 0 there, and 9 squared is 81 minus 81. Both of them will make this one. So these two are fine. All right, any questions about that? So some of these take a lot of paper is the issue. All right, on this last one, the LCD, well, I got this whole thing over here. So that's that one. Here's your LCDs here. All right, x plus 2, x plus 3. So you can see what happens here when you multiply that term right there by x plus 2 plus x plus 3. These are gone, and you're left with x plus 1 times x plus 3. When you multiply this middle term, the x plus 3's are gone, and you got 3 times x plus 2. And then over here, this right here is the same thing that's down there. So it's equal to -1. All right, now, this one's got a lot of things going on. So when you multiply these here, x times x is x squared, x times 3 is 3x, x plus 1 is 4x. And then on this side, it's 3 times x. Is 3x, and 3 times 2 is 6. And then the -1's over there by its lonesome. So we're going to put these two together. That gives us 7x, and 6 and 3 give us 9. We got to make this 0 since it's a quadratic, so we're going to add 1. So x squared plus 7x plus 10 is equal to 0. It factors as both positive. And there's only two factors of 10 that add up to be 7. There's 2 and 5. So this one takes up a lot of work or a lot of room, depending on how many steps you need. So x is equal to -2, or x is equal to -5. Hopefully you can see that if you try to put -2 in this equation, or in this first term, you're going to end up with -2 plus 2. As long as it collapses one of them into an undefined statement, we're going to throw it out. I think it also does this one. No, it doesn't, because that's -10 in the middle, and that's 4. No, that one works. -2. Let's say -2 squared is 4. And then 5 times yeah, and then this is going to be -6 plus 6. So that one right there collapses into 0, 2, but all you need to have is one of them. You can check the other one and see. So this fails as a solution, but x equal to -5 is the only solution, because that one makes it undefined. All right, so let's take a little break. If you got any questions, let me know. I'll stick around here a minute or two. We'll still have the end of class, but this is the easier part. We've gone through the hard part. I know I went a little bit fast on it, but in order to kind of hit the highlights. That's kind of the way I need to do it. We really shouldn't go over this until the last, so that's why I couldn't really change the order. But otherwise, I might go over the shorter part first. All right, this is broken into two parts, essentially. All right, so 7. Well, they got 3 examples. So let's just look at the first example. See, these should all be pretty easy by just taking and multiplying across like that. And what I usually do is put the X on this side because I like it on the right side. I mean, on the left side. So 2X is equal to 5 times 4, or 4 times 5.
20.
Yeah. So 2X is equal to 20. This one's a lot easier to solve than anything we looked at so far. So X is equal to 10. Now, just to show you on these, they're going to be a little bit easier to check, but if you put the 10 down there, this is essentially what you're always doing with a proportion problem or any kind of a rational expression. That's why when we were checking those other things, you had 3 different terms. And so what you usually do was make one of them have the denominator you needed to add and subtract to the others. But these right here, all right, the reason why you got the X there is to tell you what number you're going to put down there in order to make these things equivalent. If you divided both of this side by 2 or multiplied this side by 2, you would find out that 2 times 2 is 4 and 2 times 5 is 10. So that one checks out. Or you can divide this one by 2 and get 2/5 is equal to 2/5. Same thing. They're both equal. So again, here, I like to put that one first. These don't have a whole lot of room, so I'm going to try to squeeze it in there. And then 5 times 12, which is going to be 60. So then 10x is equal to 60 divided by 10 divided by 10. X is equal to 6. So again, if you have 5/6, in other words, we're putting the 6 down here. This will kind of give you a little bit of experience in just reading how the fractions end up being equal, because this one is exactly half of that one. Well, let me take that back. They're both equal, but the only thing stopping them from being equal is just a factor of 2 here. In other words, 2 times 5 is 10 and 2 times 6 is 12. But as long as we're multiplying the fraction the same numerator and denominator with that same number, then we've got no issue. So see if you can work out this next one here. What happens when you multiply and multiply?
X is 21.
Okay, let's see. So 3x. And on this side, 7 times 9 is 63. And you are indeed correct that x is equal to 21. Now, again, the problem that we kind of got is if we take 7/3 is equal to 21 over 9, you can even take these.
3.
Well, you can divide by 3, but you can also do this. So let's you get creative about this. 7 divided by 3 isn't what we would call is an improper fraction. And generally speaking, so this is 2 1/3 here. Oops, this one.
Oh no,
2.
I was saying 7 times 3 equals
You
21.
can. I was just trying to show that there's more than one way to do it.
Okay.
For checking, okay? You're right. And if you take 21 and divide it by 9, so you get the same thing.
Yeah.
So if you wanted to do that and checking of any of these, that'll work. Even the ones back on this page. When you go back and check, you easily could have, like on this one, 1/4 is 0.25 rather than go through the LCD thing, because that takes some time. See, 1 divided by 4 is 0.25, and then 1 divided by 6. So let's say you add 0.25 to it. So that would be point, what was it? So it's supposed to be 0.416. And then if you do the same thing with the 1024, you should get the same thing. So just keep that in mind. In general, in algebra, you're usually better off in most cases working with improper fractions, but you can also kind of just use rounding them off to to what we call decimals or mixed numbers or anything like that in order to check them. So what about this one? I would put that one first just because I like my x's on the left-hand side. And 3 times 6 is equal to 18. Now, this one will not be a whole number. X is equal to 9 halves, which it's 4.5. All right. So that's 9 halves up there, but it would be it doesn't have to, you don't have to necessarily follow a set of the rules that you were doing when you're solving the actual equation, because you need to be exact on the equation. The check-in can be, like I said, is you can kind of, I'm going to use the word fudge, but you can kind of take a few liberties. All right, these next ones, you got to remember on these next ones, these all have a binomial in one of the 4 spots. All right, and even this one down here has an X in 2 spots like this one. All right, so just what you have to remember is when you multiply that 6, you multiply times both of those. So this is 6x plus 12. Oh, and 14, that's 30, and 12, that's 42, right?
X
So
equals 5.
6x is equal to 30, or x is equal to 5 when you divide both sides by 6. And so 5 here plus 2 is 7 over 3. And 7 over 3 is the same thing as 14 over 6. So 3 times 2x is 6x. And 3 times 1 is 3, is equal to 36. So again, here we're going to have one that's not quite, it's not going to be a whole number. Hold on, let's see, did I get this right? 18 is 36, so yeah, that's 33. What happens if you divide both sides by 6? This is going to be, you can divide both of them by 3, so that's 11 halves, right? 3 goes into 33 11 times and into 6 twice. And again, for just the check-in part, 11 divided by 2 is 5.5. So again, you could put your 11 halves in there, multiplying by 2, which would give you 11. 11 plus 1 is 12 over 9 is 1.3333. So if that's 4/3, same thing as 4/3. All right, see if you can, well, let's do one of these. Let's do that last one. This one's going to have 2 x's to handle. I mean, you can handle 7 if you want, but it's just this one's going to have 2 x's that you're going to have to combine. I put the biggest one over here, the binomial. All right, so
I've got X equals -2.
that sounds about right. So that's 6x is equal to -12. So x is equal to -2. And again, on this side, it's going to be 3 over -2 or -1.5. Over here, it's -2, so that's -10. Plus 4 is -6, so 9 over 6 negative. That's the same thing, I believe, if I wrote it down right. Oops, yeah, -1/2, so that one checks. Did you get this one here? Or work it real quick? We got enough time. So this is 4 times x plus 3.
I think I got X equals 12.
All right, so I'm just going to subtract the 4x, make it easy, quick. So that's x is equal to 12. And again, if you 12 plus 3 here, you got 15. 15 divided by 5 is 3. And then on this side, 12 divided by 5 is 3. And 4 is 3. So that's correct. All right. So the only thing that's different about example 2 is you're bringing in the quadratics. Okay. So these could have 2. You factor it as x minus 8, x minus 3, x is equal to 8, x equal 3. None of these is going to create a problem in the denominator because the only one that has one in the denominator is that one. And the denominator can be anything but 0. So 8 and 3 will both work down there. All right. These are easy. I'm going to give you code tips, but just go ahead and do these. Start on number 9 and see if you can get 10. I'll be right back. So see these, because there's 2 x's, you're going to end up with x squared. And 4 times 9 is 36. Now in chapter 11, we're going to find out there's an easier way to solve these. But for now, we just got to factor them. So we got to put them over here. All right. So x minus 6, x plus 6. All right, so you can see that 6 goes in there, squares, so 36 minus 36 is 0. And negative 36 squared is also 36. So x is equal to negative 6. X is equal to 6. Well, I got them turned around, but the sign should be x equals 6. It should be a negative 6. And so if you put 6 here, 6 over 9, and 4 over 6, like I said, you can use this quick method. So 6 divided by 9 is 2/3. That's 2/3 in the skies. And there's 2/3 in the skies. So that one checks. And the same thing over here. This is just going to make both of them negative. So 6 divided by 9 is 2/3 negative. And then this would be 2/3 negative. So both of them are going to check. All right. So any other ones done? Like I said, no matter which ones you put first, I would probably prefer to put, well, the x's are going to be on the same on one side anyway, but I'm going to put these over here because I like my x's on the left-hand side. And then this is going to be x times x is x squared. And that's equal to 18. And then we're going to subtract 18. Subtract 18. So this is going to be x squared so this is x minus 6, x plus 3, right?
Yeah, that's what I got.
So that means x is equal to 6
-3.
and x is equal to negative 3. And again, if you're just doing 6, that would be 2 6, which is 1/3. Here, it would be 6 minus 3, which is 3 over 9, which is 1/3. Same thing's going to happen over here. 2 over 6 is negative 2/3. 2 over negative 3 is negative 2/3. And then negative 3 plus negative 3 is negative 6 over 9, which is also negative thirds. All right. Like I said, these are all going to do that. Let's go on to this. If you want to come back, we can, but I want to make sure that we got enough time so I can explain about how to set these up. They're really not that bad. All right. Now, with these proportion problems, they're really easy to set up, and they're not going to be like these. They're going to be like the early ones here. All right. This is why I was saying that this will be the first application that's easy. But the thing you got to notice is there's 2 units here. There's feet and there's pounds. There's pounds and there's feet. So there's 2 occurrences of feet and 2 of pounds. What I'm going to do is I'm going to put feet here and I'm going to put pounds here. That'll help me remember how to set up both of these because they have to be the same going across from numerator to numerator. So 64 to 20 is a ratio. A fraction is a ratio. So what we're looking for, as I said up here, when we check some of these things, you can just kind of bring them to whole numbers, or you can bring them to decimals, or you can do them to mixed numbers, whatever makes it easy to check real quick. So watch what's going to happen here. Now, we need to know how many pounds. How is X? How many is X? So that's pounds. So I got to put the X right there because I don't know what the partner is to 20 in order to have 28 feet of rope. So just kind of to get it straight in your head, if you got 64 pounds that weighs 20 pounds, then there's a little bit half 28. That's a little bit less than half. How much does that weigh? Well, we can kind of guess it's going to be probably less than 10 because if we halved it, but we got to find out exactly what it is. This is important for the actual solution. So what is the solution going to be?
Is it basically 64 times X and 20 times 28?
That's all there is to it. Yeah. And then solve that. And this ends up being 280, 560, I believe.
Yeah.
What happens then when we divide by? I think that comes out even, doesn't it?
I got 8.75 on a calculator.
You're right. So X is equal to 8.75. And that kind of more or less makes sense because if you take half,
8 1/3.
but watch, let's check it just to make sure.
Four.
64 divided by 20 is 3.2. Well, what's 28 divided by 8.75? It's also 3.2. So this is pounds. So the thing we report as the answer is 8.7 pounds. And as I had said, is 64, about half of 64 would be 32. So this is a little bit less than half. So we would expect a little bit less than 20, half of 20, which is 8.75. All right, try this 14. You've got miles to days, and then we want to know how many, which is our x, in days. So the variable is for the miles. Doesn't matter where you put. We can put days up here, or we could put miles. The important thing is we have to line up going across. We could have solved this as 20 over 64.
Yeah, 6
And we
4.
would still end up with the same thing, you see? So all you got to do is just line up going across. So 2.5 is a day. And then over here on the equal sign, it's 8 days. On the left-hand side, we know the miles is 200. And what we don't know is how many miles go along with 8 days. It's
640.
almost 4 times as much, but only way we can do it is to solve it. 2.5x is equal to 1600, right?
Yeah.
So then 2.5 and then divide 1600 by 2.5. I think this comes out even. Yep. So that means in 8 days, goes 640 miles. Boy, that's a long way, even for 2.5 days. I guess that's not too bad. It's a little bit less than, what, 80 miles a day, I think. So we can just find out what it is by going 8 divided by, oh, wait a second. Oh, you know why? Because I got it upside down. It's still going to work, but so see, it's still an eighth. That's essentially telling you that's an eighth of a day for every mile. Takes an eighth of the day. But if you had done it like this, you find out that that's 80 miles a day. But it doesn't matter which one you put on top and which one you put on bottom. It's just that you got to match up going across. All right, now this one's a bit tricky because you're going to set it up the same way, but it wants to know how much snow will be accumulated. So set it up, and then you got to do a little adding. So watch the wording on that one. Got plenty of time here, so I can go back up and do those other two if we want to.
Equals 8.
All right. So inches and then hours. We're lining up left to right. So here it's 2 inches. And down here it's 2.5. All right, and that's equal to 10 more hours. And what we don't know is inches. And 2 times 10 is 20. And then divide both sides by 2.5. It's going to give you, like you said, 8. 8 inches. Now, we got to be concerned about the way that question is. So if there's already 2 inches on the ground and it snows for 10 more hours and gives you 8 inches, it's 8 plus 2 is equal to 10 inches total. See that? So you got to watch out for what they're asking. Because most likely, in something like my math lab, if you had just put 8 inches in there, they might tell you, in a homework, they'll give you a hint maybe and say, well, you've gotten the amount. I don't know what they would tell you. Hopefully they give you a hint. But how much snow will be accumulated after 10 hours? And remember, there's already 2 inches on the ground. So 8 inches plus on ground, the 2 inches. So when it's all said and done, after the 10 hours, there should be 10 inches total on the ground. That makes sense?
Yeah.
Okay, so just watch that, because it's easy to just do that first part and then forget. So see, these are pretty easy to set up, and like I said, they all end up being like the first first 6 problems of the first example. All right, so for the rest of the time, why don't y'all try 11 and 12, and then I'll come behind you and see how you're doing on those. These are the hardest ones, of course, because these have the x squareds in them. Were any of y'all like Delgado West Bank students before all this COVID business? I guess not, huh? We got a new building. Well, there's a new building going to be at City Park, but it's not started yet. But that's for the nursing people. But we got a new building that's coming online like for the fall semester on the West Bank.
I've got x equals -8 and x equals 2.
That sounds good. So when you multiply here, oops, that's 4. It's x minus 4, x plus 4. This one is designed so this side's not so complicated, because remember, that's the x squared minus 16. And then plus 16. Oops. Hold on a second. I should have went ahead and something doesn't seem right. Let's see, it's x plus 4 times x minus 4, which should be, that's a 4. X minus, and then over here it's negative 6x.
Yeah, and then you bring the negative over to the left,
Yeah.
be positive 6.
Well, it looks like it's x minus 10. I don't know what I'm not saying. I still hadn't got over my. It's not as bad as it was, you know.
Oh, well, see,
Gotta
because
get
it's going to be
serious
negative
headache.
6x. You didn't bring over negative 6x.
Oh, thanks. Thanks.
So it'll be x squared plus
Yeah,
x minus 16.
there you go. Thanks. Like I don't know if I told y'all when I was out sick. Well, the week before, my son had that COVID and he was really sick. And I never did get sick because I never did test positive, but I still had a serious headache almost continually for 2 weeks. He had fever and headaches, and he never gets sick. Never gets sick. So I'm like I said, but I'm still getting some of these symptoms for some reason. And I
Yeah,
had the same thing when
exactly.
my daughter had it last year. I like got all the symptoms and then didn't get it.
You haven't gotten vaccinated yet?
Not yet. I hadn't had time because I got classes over at City Park, and they don't do the vaccinating there when I'm over there. This crazy schedule I got is I probably could have maybe tried to do it on Thursday, but I wanted a day off. Okay, so this is plus 6x. But I don't know if that's going to help the symptoms though, because like I said, I never did have it. It's crazy. I don't know if it's like,
Well, it's not a cure or anything, but
but it was
basically
just more like
it'll
maybe
stop you from
empathy for
dying
them
if
or
you
something.
get
I don't know. I just
it.
got
It'll
some.
stop you from dying if you get it.
I don't know, but you're right. I mean, that's for sure. So this is 8 and 2, right? You're right. You got it faster than I did.
Yeah.
But like I said, it's just like this headache business is crazy. And my son, he's just now getting all of his taste back. He couldn't taste things for like a long time, like well over 2 weeks, and he said he's just now getting it back. It doesn't make sense how that works. How you can feel sick but not have it. I don't get that. X is equal to 2. All right. So -8 plus 4 is 4/6, which is -4. So that's 4/6. So that's 2/3. And then this side would be -8 over -12, which is 2/3. So these check. And this one doesn't matter which one you put on what side because you got a big side. So this is x times x minus 3. All right, so x squared minus 3x 2x
That's supposed to be a plus 14. It's supposed to be plus 7.
Oh yeah, thanks. Man, what in the world? Like I said, it's just like stuff's not working right. There we go. Finally. If you do it too fast, that's why I can't move fast with this. You gotta go slow. And then minus 14. So x squared minus 5x minus 14 is equal to 0. And that's 7 and 2, right? And it's x minus 7 and x plus 2. So that's going to be 7 and negative 2. And again, you can kind of spot check them here. So 7 over 14 is 1/2. Because if you put your 7 up there and your 7 down there, 7 over 14 is just 1/2. And then 2 over 7 minus 3 is 4. So 2 over 4 is also 1/2. Same thing with this one. Negative 2 plus 7 is 5. So negative 2 over 5. And then on this side, it's negative 2 down here. So it's 2 over negative 5. And just in case, you haven't figured this out yet, it does not matter where the negative sign is at, as long as you only got one of them. This is also equal to negative 2/5. And generally, when you simplify one of these, what it does, it should be in the front. I just didn't do a little job on it. But those things are all equal to the same thing. Doesn't matter if you've got one negative sign, the whole thing is negative. All right, so if you got any questions, you can pipe up. Let me just go and make sure we know where we're at here. On Wednesday, we're reviewing. The test will open up. I may try to open it up tomorrow. I got to go in there and see. I always forget to do it because she puts strange dates on there. I don't see the point of trying to do this during class time because I know people are at home and they got distractions. So I think y'all are old enough to figure out, when to take it. Because like I said, I want to make it convenient because just because you got the class here, because when I hear people, their mics are normal and you hear a kid or something, or, they got people at home and all, it's not easy to do that. So, all right. So, we finished this today. So Wednesday, April 7th is review. And like I said, I should be able to do this for a couple of extra days. I'm going to see what I can do. They're changing this thing now where you can put like late penalties on it. Even with a test, you used to not be able to do that. So if somebody goes too late, but at least they can take it if they forget. Always have somebody that somehow forgets, All right, so this is test 4. All right, I think I already got this one set up. not use lockdown browser. You don't have to worry about that here. I don't know. It must not be in this one that you can have a late. I know you can do. Oh, hey, here. The only problem is it doesn't give you an end date, but don't worry about that. If you'll just have the penalty if you go past. So it looks like it's due on the 9th. That's Thursday night. So actually, it might be Friday night, but you should be able to work on it after that. You just get penalized. All right. Any questions?
Nope.
All right. Well, I'll see you on Wednesday. Remember that this is what we'll go over. I mean, you can bring in any questions you like, and I'd love it because, I want to answer your questions most of all, but there is a review here. She's even sent one over that has answers on it. So good news. She usually sends it over like the day before. So I don't know how I got this one. Because I don't remember getting it. I know I got it for chapter 6. All right. So I'll see you on Wednesday. Let me know. Send me an email or whatever.
Brother Chris, I have a question. Sorry.
Okay.
Why then in the practice test, in the math test spring 4, we don't have like the practice test like we used to have?
Because she must have not put one in there. Let me see.
We just have like that test straight up.
You got quizzes, right?
No, they
Was
just
there
have the
quizzes at
quiz
all?
for. They just have the quiz for 5, and it's for
All
the.
right, let me see what I can do. You're talking about chapter 7, right?
No, I'm talking about chapter 4. It said here that on April 4 we have to make that spring test 4. But
Okay, whoa. I'm seeing a practice test here. Look.
Look, I'm looking at it on my screen.
Okay.
And they said on April 11 we have a quiz 5, and we have to present like the homeworks of the week. But
Right,
it said on April 8 we have the spring test 4. So
well,
I'm a little bit confused.
What I'm seeing, and maybe you can see what I'm doing wrong, because I don't see why. Look.
I'm here on my
Okay, look.
Let me
Do you
see.
see anything wrong with my dates?
Let me see. Hold on.
Practice test 4. This should be the 9th.
Are there? Yeah, it's yeah.
Let me change it, because it's supposed to open up. It should already be open up.
But I'm like, we're gonna do it without making a practice one. We just have to make it.
What I'm saying is that you see it right there, don't you? Why can't we see it?
I don't know.
All I can do is go in and look as a student. I go here and see, because I don't see why you're not on. There must be something clicked that's that I'm not seeing about. Like I said, it's just laid it down. I don't really quite have a headache, but it's like my thinking power is all gone.
Mm-hmm.
Let's see. So you're gonna help me see.
I don't know if it's only my thing.
Okay, there was a practice test for 3, but look at this.
Go to 4. It said for 4/9 now.
What? Yeah, I just changed it because that's what day well, actually it should be 4/8 because that's when the test ends. So the 8th is Thursday or whatever.
But what, I cannot see the practice test for the 4th section.
See right here?
Yeah.
You cannot see that.
Oh, I don't know what I cannot see it. Let me see again. That's what I'm like. It's like,
go into assignments, click on assignments, because this part's just like what you got.
I just have for the practice.
And then go up here and click on quizzes and tests.
Let me see. Quizzes and tests. Let me
You
see.
probably got it set to homework or something. I don't know. If you got to click for quizzes and tests.
Where? Can you do it again so I can try to
See that?
Okay.
If you just have homework, you're not going to see the quizzes and tests. I mean, you can see it in course home, but I'm saying is you should be able to see this right here.
Let me see.
Because I got it. And this is my student view. This is what I see as a student.
I don't. Okay. Okay, I see it now.
Okay.
Okay. Thank you, Professor Chris.
Over here, you see it. I just don't like this view, but they've got it over here too.
Yeah.
I just don't trust this because they don't put everything there. I don't understand why this is.
Yeah, and I was looking through assignments, but I just didn't click like quizzes and tests.
Yeah, I mean, you gotta either have all, and I don't know what decides which one you pick, but you either gotta have all, which does all the homework and the quizzes and tests, or you gotta do quizzes and tests, and then you'll see there's few of them to see.
Okay.
All
I
right.
see it now. Thank you, Professor Chris.
All right, you're welcome.
Have a good night. Bye-bye.
Bye.